Hi. Hooray. So tomorrow, oops, I don't want to do that. Tomorrow is your paper one exam. So if you're not in class today, you're taking another Cambridge exam. Um, I am just going to run through paper one with you. So obviously you put your name here. Um, Center number, we'll give it to you. But center number is always US 373. And then your candidate number, which you'll need to know there on your testing passes, and then yeah, you'll need to know them. They're also on all of your Cambridge things. Okay, so this is going to be an hour and 45 minutes long in paper one. Paper one is not going to assess you over skills, so you're not going to have to design any sort of experimental setup or anything like that. I'll go over those types of things and those types of questions for paper two when you guys finish with paper one. You shouldn't have to do any type of graphing on this. You may have to read graphs, but you're not going to have to do any kind of graphing. Okay, as discussed in class, a black or a dark blue pen. You can use a pencil for any diagrams or graphs. So remember, label lines on a biological drawing need to be done with pencil. And, even if you're doing a label on something, it needs to be with a ruler as well. But again, graphs shouldn't be assessed on paper two. And then, yeah, along with that pencil, like the eraser needs to be like super solid. None of the cheap pink erasers that come with, like, if you don't prepare for this test and you're just hoping that Cambridge will supply you with basic writing utensils. Don't do that. But definitely we'll need a ruler tomorrow, a pencil with a solid eraser, and then a pen. And calculator, of course. Okay, you're gonna write your answer to each section in space provided. If you run out of space, you'll raise your hand and ask for a continuation booklet. And on the continuation booklet, you'll just open it up. It's a bunch of blank pages, and you'll say, okay, I'm finishing question 2, part B, II, for example, if that's the one that you need to keep writing about. You will not get, there is not extra graph paper. Don't be using any sort of whiteout. Do not use erasable pen. If you make a mistake, you're just gonna, with your pen, go right through it. And in this class, I know I just did the double line, but it doesn't matter. If you put a line through it, they're gonna disregard it. I know in some classes like history, they're like, if you put one line through it, they'll still grade it. No, there is no grace like that. If you wanted to write it, then you wouldn't have put a line through it. If you put a line through it, you don't want it read. Do not write any of the barcodes. So you don't want to write out of the area either. And I showed you in class what that looks like. Where they're going to scan it, you won't write out of the area. I'm confident you won't. But in case you're daydreaming, you don't want to do something like this. No writing on the barcodes. You may use a calculator. You absolutely should use a calculator. And you need to show your work, all of your work, even if it's multiplication or division. Remember, they will give you some grace for that, even if you write down the wrong answer, and then use appropriate units. Units are always given to you, so you don't have to assume that you know them unless they ask, like, what is a suitable unit for this? And they're talking about maybe like depth of the ocean. Well, then you want to do like meters or kilometers. 75 marks total, an hour and 45 minutes will give you about a minute and 40 seconds per question. There you go, a minute 40. Okay, and right away, I always say, highlight your marks right away. If you see something and you want to brain dump, go for it. Right, like right here, I see this, like, okay, this is like species name. Like I said, when these are given to you, notice the genus is capitalized, the species is lowercase. When these are given to you, most likely it's going to be used somewhere. So it says label the anal fin. 1 mark. You may easily forget that because you're not looking at the bracket and there's no line associated with it. Total 12. Maybe that's something you want to circle. So like, okay, you have 12 right there. Here's 7. right? So you want to make sure that you have at least, we're at 12 and 7, so now we're at 19 total. Maybe just keep that in mind if you have time or before you do it to make sure like, okay, I have highlighted 75 marks. There's 12, then we had 19. So now we're looking at like 31. Ooh, productivity. Maybe you see that and you're like, oh yeah, Miss Parrott said rate. Don't forget to say rate. And then there's units with it too. What was I at 31? There's 14. So now I'm at 44. There's 20, right? 64 I've covered. Okay, of course. Why? Why make a mistake? Where did I'm sure what some of you guys are like, oh, Miss Parrott, you counted wrong. I'm sure you have it. What was it? 31. The other one was 12. Huh, okay, I don't know where the mistake is, but that's something I wouldn't like spend too much time on by any means. If you're like, I'm only getting 74, it's probably a counting error somewhere. Either way, I would definitely go back then when the test is over. And then just double check that you've got them all. Yeah, okay. I'm not even taking my own advice. All right, we've done this in class. So you're looking at cartilaginous fish and then bony fish. I'm not going to write them all in here because we've already done it together. But I will like highlight them so we can just go over it one more time. So you have gill slits, caudal fin, gills, scales, swim bladder, dorsal fin, denticles, and externally visible lateral line. Write each feature in the correct position on figure 1.1 to show which features are present in cartilaginous fish only, present in bony fish only, and then present in both. Okay, like I said, we've done this in class before. For cartilaginous slits, it's gill slits, you can see them, and denticles. Denticles are what like we would call scales, but they don't have scales, they have denticles, much harder. Caudal fin, both, gills, both, scales, bony fish, swim bladder, bony fish, dorsal fin, both, externally visible lateral line, bony fish. Bony fish, swim bladder, scales, okay, and then they all have the rest. Okay, so what's in yellow will go here, what's in blue will go here, and then what's in pink go here. And Friday, when I did the review after school, we did practice what if it was like the different plants, a marine plant versus, a seagrass versus a macroalgae. Macroalgae, I don't know, just to cover it really quick, where they have a hold fast, a stipe, an air bladder. That air bladder helps keep them like buoyant in the water and keep them closer to sun penetration and sunlight. So the hold fast attaches to like a rocky substrate. Help avoid some wave action, etc. Stipe. Cast bladder. And these are blades. The seagrass is the one that has the roots with it. The rhizome, and then the roots. and they help anchor each other. So even if one comes out, the rest will still be there. These are marine grasses. They could flower. Label the anal fin on figure 2. So every marine organism, or like fish, things that swim, are going to have a pelvic fin for sure. That's their first fin. If they have an anal fin, it's the second fin, and typically cartilaginous sharks, cartilaginous fish do. So for labeling, you want to actually touch the structure. You don't need to make a dot, but you want to be touching the structure with the ruler, and I don't have a ruler on here. You're going to do a straight line, and then you'll label it. So we will do, it says anal fin. Notice I'm not going to highlight it. I'm not going to highlight it, but notice that this is written horizontally, right? I'm not like writing anal fin like this, like that's, we're not going to do that. Horizontally, it's made with a ruler, ideally, and yeah, there we go. So that one's done. Okay, you're looking at the classification of the blue shark. Complete the 4 spaces in the tables to show how the species is classified. So you got to remember that ridiculous mnemonic I gave you. Darn it, King Philip can't order fried goat stuff. C is for class. O, order. F is family. Okay, and then we are not gonna, you don't have to italicize your answers, but the genus and the species, and you're like, Parrot, you said we didn't have to remember this. You don't, it's right here. There's always answers given to you. So Prionis, capital, capital. Remember this, I have to be very intentional to not be writing all uppercase. Okay, there's my 2 marks. Explain the meaning of epipelagic. This has 2 parts to it. Epi and pelagic. Epi is going to mean the top of, but they don't float on the water. They're the top surface of the water. We did look at the different layers of the ocean. There's the epipelagic, the mesopelagic, which is the middle layer in that. This is from 5.1. I gave you guided notes for that. And the mesopelagic has the lowest amount of oxygen, followed by bathypelagic. And bathy means like the deep area, but then the abyssal pelagic is like the abyss, like the never-ending dark. If you're at a trench area, though this is not in your syllabus, that was the hadopelagic. Hadopelagic. All right, so this is going to be, it's on the like surface of like the top 200, within the top 200 meters, so with light penetration. And pelagic means open ocean. So open ocean. And then we're going to need to have something like, I know I said don't say and, but yeah, so we'll have to figure a different way to say it. Open ocean period within the top 200 meters. Or you can say top surface layer and then something about it like high light penetration, because that literally is what the epipelagic is. It is also called the photic zone, but that is not a part of the mark. If you're about to call it the photic zone, that's not its definition, but consider then what that means. State the trophic level of the blue shark in this food chain. And notice you have a big open area here. That's definitely going to be, you need to do something with it. All right, so a food chain just shows one feeding relationship where a food web is interconnected feeding relationships. It is not a question, but it's a question that I typically ask you. What do the arrows represent? Arrows represent the transfer of energy or biomass. And if that's a 2-mark question, these are the only 2 marks that come for it. The direction of energy transfer, the direction of biomass. Okay, state the trophic level. Remember, levels are numbers. So we're not going to say consumer, you're going to give a number. Phytoplankton is always trophic level 1. They are producers. Then the first eaters, 2 primary consumers. This lanternfish is 3 secondary consumers. Squid is 4th, your tertiary consumer. And then blue shark is the quaternary consumer. That's the 5th trophic level. And in this situation, it's the apex predator. Trophic level for the blue shark is 5. Moving on. Blue sharks also feed on pelagic red crabs. Pelagic means open ocean. Feed on, they eat. You can like simplify words for yourself. Like anytime I see concentration, I will always simplify it for myself. So they feed on pelagic red crabs. So blue sharks also eat that, which, and they're talking about the pelagic red crabs then, like those pelagic red crabs feed on, so they eat phytoplankton. Add this information, it's 2 marks. So they're looking to see, do you have the arrow pointing from phytoplankton into the pelagic red crab and then that red crab to the blue shark? If you're going to ask, should I use a ruler? When in doubt, use the ruler. Unless it said sketch. If it said like sketch a pyramid of energy, right? They just need to be stacked on each other centrally with like an approximated proportion here, right? With obviously this is going to be the largest because this is the producer. This would be like a pyramid of energy. Not a pyramid at all. Okay, I'm gonna write the whole name. Pelagic red crabs, right? That's blue sharks feed on the pelagic red crabs and they feed on phytoplankton. So the red crabs are eating phytoplankton. Phytoplankton is going into their stomach. It's a way to simplify what that arrow means, although that is not anything you could get correct on a test. This is what the arrow means: the direction of energy transfer, direction of biomass. Pelagic red crabs get eaten by the blue sharks. So now I'm going to do that. Okay, and there's 2 marks. Trophic level is an organism's position on a food chain or a food web. Feeding level. Explain, command word, why. Which food chain allows a greater percentage of energy captured by the primary producers to reach the blue shark? So if you're going from your phytoplankton over to the blue shark, which one is going to give them the most amount of energy? Is it phytoplankton, so plankton, lanternfish, squid, blue shark, or phytoplankton, pelagic red crabs to the blue shark? Consider that every single time you have a transfer of energy up a trophic level, you only get about 10% energy transfer, right? And that'll change depending on if you're eating the whole organism or not. Is it easily digestible? Is it a simple species like 1 cell big? Or does it have bones and denticles and a lot of proteins or cartilage? Can an organism be eaten in 1 bite? Is the organism that you're feeding on trying to swim away and get away from you and avoid predation? Those are things you want to consider. Is it like you're just eating seagrass? And so if you're feeding on seagrass, then you're not going to be eating the rhizome that's down here. You're not going to be eating the root structures. If it's kelp, you're not going to be eating the entire macroalgae. Okie dokie. This is going to be the one with the red crabs. And then the reason why is going to be because it's a shorter food chain, right? Because you're going to say this is the one and then explain why. It's a shorter food chain. There's less energy loss between trophic levels. They want to know which one's going to give it the greater percent of energy. So one way for your why you can say is it's a shorter food chain. Or, and it doesn't say you're not limited to just two, like suggest and explain one reason, but it is 2 marks, right? So here's your one answer, that's 1 mark, and then this is going to be the other mark. Or you could say there is less energy loss between trophic levels. If you're going to ask, like, am I allowed to say BTWN, like between, I wouldn't. In England, I don't know if they say that. I don't know if they say BTW, like, by the way, I know it's very common in college to use this energy instead of writing energy, ENERGY every time. But if you have to ask, like, does that translate to England? I don't know. I don't, I've never had the pleasure to live there. So I don't know. I don't know. If that's the case, then I wouldn't. Things you can definitely do is like this change in, or this, which means partial negative or partial positive. Those are things that are definitely valid. All right, the next one, you guys have had this as a test question. Okay, if there's any lag, I'm sorry. All right, so we're looking at a tide table for a sandy shore, though it's not a part of the question, just easily erodible. Things you want to add on as soon as you see it: erodible. It's porous. Can get submerged. Or completely dry out, and this would be at high tide. Over here is low tide. Same with the shorthand. A lot of you guys ask, can I use the arrows? I don't recommend it. I do that so that we can write things shorthand in class, but I don't recommend it, not when this is like the test you've been preparing for. Because what if they see it as increasing tide and decreasing tide, or up tide and low tide? If they're not using it all the time, then they won't necessarily be making sense of it like we do. Okay. One last thing to put on there is you need to be able to burrow. All right, there was a full moon on July 15th. Okay, full moon, that's going to be a spring tide. Full moon, also the new moons. This is when spring tides are going to be when the gravitational pull is greater between the Earth, the sun and the moon on the Earth. Remember, like, tides are caused by the gravitational pull of the sun and the moon on the Earth. On the Earth. Tidal range is the difference in height between high tide and low tide. Okay, and this is when the Earth, moon, and sun are in alignment. Although this isn't necessary for this question on this page, but just to throw some facts out there. Earth and sun are in alignment, or you could say 180 degrees of each other. Remember the Earth, moon, and sun, but it's only the moon and the sun. It's their effect on Earth, pulling on Earth. And this caused the greatest tidal range. All right, there's the lunch bell. So hopefully we'll get this done in the next 30 minutes. All right. This was a question that I gave on your test, and then people were like, what? But so just read it carefully. Tidal range is defined as the difference between a high tide and the following low tide. And I've seen before on tests where you needed to say height, right? Because I would even tell you guys, like, what are you measuring though? When you're measuring a tide, you're measuring how high it is, right? And it's in meters. You can see that there with the little m given to you on the data table. Okay, if you had to graph it, which you don't, but this is your x, this is your y, right? So how is time, which is definitely correlated to the rotation of the Earth, and then the moon rotating around us, and us rotating around the sun, and then how is that affecting the height? There's your y, but you don't have to graph it. So calculate the tidal range. On the shore for July 15th, they already give you your unit, which is good. You should definitely show your work. And so you're starting off 0.26, and then at 7:45 a.m. you're at 4.09. So this is definitely your high. Then this has to be low, and then it goes 0.42. Here's another low. That's at 1:11 in the afternoon. And then 8:03 p.m. you're back at a high again. And it says a high tide and the following low tide. So this is what you needed to subtract. Use your calculator. You don't want to make any kind of mistake. When you subtract that, you're going to get 3.67. All right, and when you guys had this on your test too, I also said don't just be vague and say weather or air pressure. Like what kinds of things would do that? So state 2 reasons and only 2 reasons. The first 2 unique answers you write, whether it's on this line and then this line, those will be reason 1 and reason 2. If you write below here, that's more than reason 2, then it doesn't, like if you wrote a third reason, don't bother, they're not going to read it. If you gave an answer right here and then you went right here, that's how we read in English. We read from left to right. They're going to say this is reason 1 and then this is reason 2, no matter if you wrote something on line 2. That shouldn't be like new news to you. You all know that. Okay. The tide could increase, right? So there could be greater than predicted. This is the tidal range, so the difference between high tide and low tide. Okay, it could be different. So like maybe what if the high tide was higher? Right? Things that could make your high tide higher. Let me just sketch out, it's like a quick little shoreline here. Okay, so what if this was like your normal high tide mark? What if you had winds blowing onshore and it's actually pushing water and piling water up? So now your water level's like this, right? Just to throw some facts out there, an onshore wind will cause downwelling. Okay, so that could make it higher. So that could be something, and that would change your tidal range. Put that in parentheses. High tide could be higher. And so we can answer, like, what if the high tide was higher? Then you're taking a bigger number, subtracting from a smaller number. That would still give you a bigger tidal range, right? The range is the difference. We can also answer, well, what if your low tide got lower? Now you're subtracting a smaller number. So your high tide's still going to be its normal high, but what if something made the water level seem even lower? So now instead of the low tide maybe being at 0.4 meters, what if something now caused it to become like 0.27 meters or something? So that will still cause there to be a greater difference than predicted. So things that can make the high tide higher. All right, make it a little bit thicker. You could have onshore winds, or like I said, like winds blowing onshore, you could describe it. It's literally pushing the water. Or you could have low air pressure, and this would be like your mark number 2. You could also call this a storm surge. I'll remind you what that looks like. I don't know why, like, you couldn't say potentially like the high tide could be higher because of like onshore winds, right? And then like your low tide could be lower, maybe because of like higher air pressure or something. I don't know why, because I guess maybe you could say onshore winds and then offshore winds, and then it's kind of contradictory, and I don't know. But for this mark, if you were going to talk about the high tide being higher, your 2 reasons then needed to be about the high tide. If you wanted to discuss low tide, your 2 reasons need to be about low tide. So in class, I kind of drew this out. When you have a hurricane, I'm going to erase this too. When you have a hurricane, remember your lowest area of pressure. Now, you didn't have to learn about hurricanes in this mark or in this syllabus. They used to. In the northern hemisphere, remember, things turn clockwise due to the Coriolis effect, which is because of the rotation of the Earth. The Earth is spinning. And so the things that are not nailed down to Earth will spin, like our clouds and our water. Okay, well, where the air pressure is its lowest, which is going to be right inside of here, low air pressure, low air pressure, low air pressure, your water actually can rise, which is what made Hurricane Katrina so bad. So instead of it, your air pressure pushing this down and keeping it down, where it's very low in this hurricane, which is actually the low pressure, is what makes it a vacuum and causes things to actually get like sucked up in there because the air is really warm and that moist water is very warm. Warm things rise. That's going to cause all this air pressure right above your water line to be very low. And so, in result, your water actually can rise a little bit. So it gets a little bit higher than it normally is because now you don't have as much pushing it down. You just have a little air pressure pushing it down. So once we have that, like now, instead of your high tide being right here on average, now maybe the water, because the pressure is so low, is able to come up to here. So that would be the low air pressure. Likewise, though, on usually like more calmer weather days, you can have like air pressure being a little bit higher. And that just means you're going to have just more air pushing down on the water and making it maybe a little bit lower than it should be. You're just literally compressing the molecules, like squeezing the water. So I'll put that one here. Low tide could be lower. You don't want to say low tide could be higher than normal because then that's going to completely change the whole point of tidal range and subtraction. You either want to increase your highs or make your lows much smaller. So low tide could be lower due to, so likewise, we could say the high air pressure. And that's not called a storm surge, that's just what it is. Or you draw the other part of this shoreline right here. So the other area of this ocean. Okay. What if you have offshore winds, right? Pushing the water away from the shore. Like if you had to cool something down, soup, coffee, whatever, and you're literally like blowing the water or whatever was in your cup away. Sometimes you do it so much it spills over. But instead of your high tide mark, maybe the average is like right here. Now you're going to cause that average to come down to maybe like right here. Sorry, not the high tide. This is making low tide lower. Low tide average. Remember the offshore winds causes upwelling. The movement of cold, nutrient-rich water from the seabed to the surface caused by offshore winds. When upwelling happens, you have an increase in nutrients. Immediately, that's going to increase productivity of your producers, mainly phytoplankton. So they're going to increase biomass, which means they're increasing like the organic material, the glucose that they're making, by one, doing photosynthesis faster and being able to reproduce. They can make a lot of themselves really quick, which means you're going to have more organic material or a food source for your consumers. And if this question goes to fish, then maybe you could say these would be zooplankton, trophic level 2, and then obviously your trophic level 3 if there's fish. So producers get eaten by zooplankton, zooplankton get eaten by fish, and then maybe that's going to create money for fishermen. You've done a question like that. Okay. Lots of facts on there. Okay, next one, the maximum tidal range at the same shore on July 22nd was 2.4 meters less, and that's the range. So that's the difference between high tide and low tide. It was 2.47 meters less. Don't know why I would have put another 7. Then on July 15th, and that is between like 22 minus 15, that's 7. So that's like a week difference. You don't need to know much about moon phases, but you do need to obviously know that they change. There was a quarter moon on July 22nd, and we know quarter moons and crescents have a very low tidal range. I keep putting L, tidal range, which means your high tide is at its lowest, and then your low tide is not that low, it's like at its highest. So your low tide isn't that low, your high tide is not that high. All right, so explain reasons. So that's going to be why and how. For the difference in tidal range, so again, the difference between high tide minus low tide at this location on these 2 dates. So why is there a difference between July 15th, when we see the tidal range is 3.67, and then July 22nd, when they said it was actually 2.47 meters less than what it was. So 3.67 minus 2.47 meters. Okay, so July 22nd, it's going to be 1.2, right? But they don't ask that. Got to give reasons for why that would happen. And it's all going to be about the alignment of the Earth, Moon, and Sun, and then the gravity that they are imposing on them. You may use an annotated diagram for your answer. Man, when in doubt, if you don't have the words, draw it out. Like I've always said on a test. And if you see this question and you're like, oh my gosh, Miss Parrott went over this and I don't remember it, I did not study it. Move on. Just get out of there. Your brain will start digging you a big hole and you don't need a shovel right now, right? Seeing this question. I couldn't give you many examples of this because this is the first time they had this question on the syllabus. This is a brand new syllabus. So yeah, we'll move on from that then. If you see this one, like describe how sodium chloride dissolves in water, you're like, wait, I know sodium chloride is this. And oh yeah, shoot, water is polar. Brain dump. and then move on from it. Knock out things that you are confident with. You don't have to get an A. You don't have to get a B. You just need to do better than failing. Do better than the person next to you. Okie doke. So that's what you're going to answer. So say why and how, the reasons for the difference in tidal range. So the biggest thing we're going to want to reference the effect that the moon and the sun have on Earth. If you say the gravitational effect of Earth, no. Earth's own gravity upon itself does not cause tidal differences. It's the pooling of the Earth's water from the moon and the sun. When the moon and the sun are pooling on the Earth's water, that's what's causing it. Because water, same with clouds, they are not nailed down. So water can get pulled out to the sides. And I have like pretty short, quick videos and then picture examples of this on the tides, which I think it's maybe 2.2. All right, so just mentioning the gravity or gravitational effects of the sun and the moon. This would be one that you would, common sense, want to put an and, because you're not going to say the moon, period. I don't imagine you get that wrong. It's the moon and the sun pulling on Earth. Or some kind of statement like that, like the moon and the sun pull on Earth's water, or like you need to say gravitational. A gravitational pull on Earth's water is caused by the moon and the sun, or the moon and the sun have gravity and they pull on the Earth's water, something like that. Okay. This small little tidal range right here, July 22nd, we know then is going to be a neap tide. So we can talk about the alignment, which is why they said you could use an annotated diagram. So if here's Earth, here's the moon, doesn't have to be drawn to scale, obviously. Here's the sun. There's your 90 degrees. Where here we have Earth, sun, moon, 180 degrees. Here's the water bulge from it. Very minimal water bulge here. So over here, they would all be experiencing a very high tide. Same with over here. Lots of water getting piled up on that side, where on the back of the Earth, there would be a low tide. Same with on the front of the Earth. Those areas would have a low tide. Okay, remember something to consider. They said, explain reasons for the difference in tidal range on these two dates. So you definitely want to consider those two dates. And so what does that mean to be a neap tide? And I don't like that word with, I will say to Earth, like in comparison and in relation to. Obviously, you could use the at symbol. You can also use the angle symbol because that is like mathematically and scientifically valid. Okay, and then another little detail, the sun and the moon's gravity are almost like in opposition, right? Like the moon is pulling in this direction and the sun's pulling in this direction. They're working against each other. The Earth and the Sun. The Earth and the Sun, their gravitational forces are opposing each other. Or something saying like the gravitational force during a neap tide is like less. Okay, and now it's not that gravity is increasing. Gravity is not getting stronger. It's not like the masses of the Earth, of the Sun and the Moon are increasing, causing gravity to be stronger. Um, on a spring tide, the gravity is going to be working together, so they're like a combined effect. It's not it's not that that gravity is all about something's mass. So if you don't want to say terms like the gravity is stronger, it's not, because it's not like we can jump higher during a spring tide and we can't jump as high during a neap tide. All right, so then for July, and this is for 722, for July 15th, there's a spring tide. Okay, I can annotate a diagram, or I can say Sun and the Moon are aligned with Earth. Their forces, or you can say gravitational forces, they're acting together, like they have a combined effect, or they're pulling like in the same direction. All right. Okay. I can't pause this and then return to it, but I do need to make some copies for A level today. So I'm gonna stop this one here. I know this is the one that you guys all want me to do, and I will. But I'm gonna stop this here so I can get my stuff done for the afternoon really quick. And then pick back up on this when I can, or at the end of the day for school. All right.